out the sides.
New formula.
So I could either use side C as a base or side B as a base. Where I have to draw one, we'll use B. So all I have to do is find this height. And that's in the right triangle.
Ooh,
With an
yeah.
angle A and hypotenuse of C. So H is C times the sine of angle A. So now that we have a base and a height, right down the area is 1/2. Here, let me write out area since I used the letter A for something else. Area is 1/2 the base times the height. And of course that could be in two other forms. Could be 1/2 AB sine C, or it could be 1/2 AC sine B, depending on what side you know. But if you have two sides and the included angle, it's kind of a law of cosines thing. Okay. Now, let's get out our analytic geometry hat.
Huh?
And do you remember the formula for the area of a trapezoid?
No.
Well, let's do that first.
Like a Sesame Street.
The area of a trapezoid is 1/2 the sum of the bases times the height. Okay. So suppose I'm given the three coordinates. X1, Y1, X2, Y2, then X3, Y3 in a coordinate plane. I want to find the area of that triangle. Well, if I drop perpendiculars from each of the vertices, this is X1, this is X3, this is X2. Then I have three trapezoids. I have the tall one on the left. I have the tall one on the right. I have the wide one in the center. So if we add the two tall trapezoids and subtract the short wide trapezoid, we end up with the area. So let's do that. The tall trapezoid on the left, its bases are Y1 and Y3. And its height is X3 minus X1. So we have 1/2 the sum of the bases times the height, because we're looking at the trapezoid not in this direction. We're looking at the trapezoid in this direction, B1, B2, H. So we have the trapezoid, tall trapezoid on the left, tall trapezoid on the right is plus 1/2 of Y3 plus Y2 times X2 minus X3. And we want to subtract from that the fatter one here in the center. And let's see, Y1, Y2. Y1 plus Y2 times X2 minus X1. Okay, I want to do all that algebra.
That's a lot of algebra.
Okay. I'll factor the 1/2. And then let's do each of these. Y1 X3 minus Y1 X1 plus y3 x3 minus y3 x1 plus y3 x2 minus y3 x3 plus y2 x2 minus y2 x3. And it's going to be minus these factors, so it's going to be minus y1 x2 plus y1 x1 minus y2 x2 plus y2 x1. Okay, some of those terms add out. Minus y1 x1 plus y1 x1. Plus y3 x3 minus y3 x3. And then we ought to have a there. Plus y2 x2 minus y2 x2. Okay. So I have 1/2 of, and I'm going to change the order I write these. I'm going, where are they? Okay. I won't change the order.
That confuses me anyway.
Let's look at a determinant. Anybody remember from college algebra? A, B, C, D, E, F, G, H, I. Anybody remember that?
Oh, yeah, yeah.
No.
Yes.
This is A times E times I plus B times F times G plus C times D times H minus A times F times H minus B times D times I minus C times E times G.
Uh-huh.
To get that, A, B, C, A, B, D, E, F, D, E, G, H, I, G, H. We're going to add AEI plus BFG plus CDH down and right. AEI, BFG, CDH. And we're going to subtract AFH, BDI, and CEG. Subtract AFH, BDI, CEG. This is my favorite term. It's a cyclops. Yeah, the BDI.
That's hilarious.
So, I just point that out for
Purposes of that?
purposes of that, but it's not that way yet. So let's look at the determinant 1, 1, 1, x1, x2, x3, y1, y2, y3. I'm going to multiply that by 1/2, and then I want to take the absolute value of the whole thing. The reason I want to take the absolute value of the whole thing is, if they are ordered the direction that I ordered them counterclockwise, then you'll come out with a positive answer. But if the points are ordered clockwise, and you do this, we'll come out with a negative answer. So if we take the absolute value of the end, we have the right answer, maybe. So let's see this. This gives me, in this direction, x2, y3, and using the same one in the other direction, minus x3, y2. And this one gives me x3 plus y1, and in the other direction it gives me minus x1, y3, and the last one gives me x1, y2 minus x2, y1. keep in mind though, I wrote those in the opposite order, but let's see. Is there an x plus x2, y3 over there? Plus x2, y3. Okay. Is there an x3, y2 minus x3, y2? Minus x3, y2. Is there an x3, y1 over there? x3, y1. Is there a minus x1, y3? Is there a plus x1, y2? Plus x1. Plus x1.
At the bottom.
Oh, at the bottom. Oh yeah, x1, y2. And lastly, is there a minus x2, y1? So this has exactly the same terms as that, and it's easy to do. We don't have to find the trapezoids. All we have to do is find the value of that determinant. This does all that.
Okay, that makes more sense.
So let's do maybe one that
Thanks.
we know. Yeah. Let's just do some points. 1, 2, comma, 5, 1, comma, 3, 6. Okay. So 1, 2, 5, 1, 3, 6. We throw them into this. 1, 1, 1. The x values are 1, 5, 3. 1, 5, 3. The y values are 2, 1, 6. 2, 1, 6. And since I did that in counterclockwise order, multiply by 1/2, I should get the area of the triangle.
Can you do them in clockwise?
No, it's counterclockwise. If you get the choice, choose counterclockwise and it'll come out correct. So,
Okay, so
1 times 5 times 6, minus 1 times 3 times 1, plus 1 times 3 times 2, minus 1 times 1 times 6, plus 1 times 1 times 1, minus 1 times 5 times 2. Times 1/2. 30 minus 3 is 27, plus 6 minus 6 is 27, plus 1 is 28, minus 10 is 18. Times 1/2 is 9.
interesting.
Now let's do it the trapezoid way. Okay. And this trapezoid has heights of 2 and 6, for an average of 4, and a base of 2. 4 times 2 divided by 2, this one's 4. Now let's look at this one. Has a width of 2 and a height of 1 and 6. That averages 3.5. 2 and 3.5 times 1.5. Oh, yeah. Oh no, I did that wrong. I didn't divide it. This should be 8. This is 7. And this one down here has a width of 5. Somewhere I made a mistake. No, it has a width of 4 and heights of 2 and 1. The average of 2 and 1 is 1.5. 6. 8 plus 7 plus 6, okay, I missed somewhere. Anyway, it should come out. Oh, that's right. Oh, did it? What was this distance? This distance is 2. And the sum of heights is 8, so 2 times 4. This distance is also 2. And the heights are 7, which is 2 times 3.5. And the last one, this width is 4, and the heights are 2 and 1. 6, 7, 8. Did I do this wrong? Did I make a mistake in this is the question. But if you do this right, I'll recheck here. 30 minus 3, 6 minus 6, 1 minus 10. 30, 27, 33, 27, 28 minus 10 is 18 divided by 2 is 9. So, maybe I did something wrong there. But in any event, either way, you should have come out with the same. So, that gives us another formula. The area of the triangle with points x1, y1, x2, y2, x3, y3 is 1/2 of 1, 1, 1, x1, y1, x1, x2, x3, y1, y2, y3, absolute value of that result, depending on the order of the points. So that gives us another way to find area of a triangle. Now we have some more. Who would have thought that we'd have more? About a bazillion years ago, there's a Greek mathematician, Hero or Heron, depending on different writings, sometimes they drop the end, sometimes they wouldn't. So Heron of Alexandria came up with a formula. If you have a triangle with sides A, B, and C, any sides A, B, and C, then its area was, I'm going to write it down and explain it, S times S minus A times S minus B times S minus C, close. Where S is the half perimeter, which is, the perimeter is the sum of the sides, divided by 2. So let's pick any old triangle. Seven, 6,
9.
12. Well, let's pick an odd number, 11. Because I want the half perimeter to be nice. Okay. So the perimeter, 18 plus 6, 24. The half perimeter is 12. S is 1/2 of 6 plus 7 plus 11. 13 plus 11 is 24, divided by 2 is 12. So my area is square root of 12 times 12 minus 6 times 12 minus 7 times 12 minus 11.
This is weird.
And let's see. 5 times 6 is, well, let's do some reducing. This is 2 times 6. The 6 comes out. What's left is 2 times 5. 6 times square root of 10, if you simplify that. The square root of 360 is 6 times the square root of 10. So we have the area. Now, we were able to check this. If you use your law of cosines, find one of the angles, then use, if we find this angle, then be 1/2 of 11 times 6 times the sine of that angle. And you should get the same number. Okay. So we have Heron's formula, or Hero's formula. And we'll look at another way on Tuesday. So let's write all these up here.
And what section is this? What chapter?
7-3.
7-3. Okay.
Yeah. Right after law of cosines.
Okay.
Areas of triangle. Okay. 1/2 base times height. 1/2 base times product of two sides times the sine of the included angle. Then we had 1, 1, 1, x1, y1, x1, x2, x3, y1, y2, y3. And then we had Heron's formula, which is s times s minus a times s minus b times s minus c, where s is 1/2 of a plus b plus c.
I have a question.
Yes.
The top row of 3 ones.
Yes.
How does it always going to be 1 regardless of the points?
As long as we're in a plane, it will be 3 ones. If we're in space, it changes a little.
Oh,
I, J, K, x1, y1, z1, x2, y2, z2. Oh. Okay. I'll figure that out next time. But you can also do it as in 3 space with points x1, y1, z1, x2, y2, z2, x3, y3, z3. And then these are.
Can you show the pattern of how you got the answers, like slowly, so we can go point to point to point, as far as trying to figure how to do the practice and all that? Because I'm so confused. 'Cause you're just all over the board on that one. Left to right, and then
then goes left, right, and then
left to right, and then across. Okay.
If you do a pattern here, AEI plus BFG plus CDH minus EG minus BDI minus AFH.
It almost looks like a I want to say like a neutron.
Oh, yeah. I was thinking of Celtic knot.